EPLANT Piping Basic tutorial. This video shows how to separate an isometric in different sheets when it is too big for a single sheet. To begin with, let's check the connectivity of the line before extracting it. Although during the extraction a connectivity error would be informed if any, this specific command performs other verification as well, and it is the basis for fixing any error. We check also the option to look for the connection with other lines and equipments. The connectivity is correct and the line is currently connected with other lines in 6 different points. Before extracting the isometric, we are going to change the view from sheet to 2D wireframe. This alone will speed up the process by an order of magnitude. We take at last the extraction command. Also for complicated lines, it is a matter of few seconds. This one is the output file. We open this isometric that was created in the project ISOE folder. We can easily see that the drawing will not fit in one sheet. Although there is an option to automatically separate the drawing in different sheets, respecting in each one the drawing area, it is better to manually control the separation to avoid arbitrary separations. With the manual setting, the separation is performed whenever an isometric cutting symbol is found along the piping line. In any case, the drawing is always centered in the drawing area. Let's come back to the 3D model to place these separation symbols. This symbol can be placed using the general command where all the defined components can be selected. We are going to cut the sheet in this elbow. And also here before this elbow. Selecting the component just placed, we can verify that it is the cutting symbol. We extract the isometric again. We can check the separation mode that is set as manual. And we extract the isometric once again. This one is the first sheet. This one is the second sheet. And this one is the last one. Let's open all these sheets in sequence, starting from the first one. We see here the continuation note in the second sheet. We open the second sheet. We see here the continuation note in the first sheet. And here the continuation note in the third sheet. Here the continuation note in another line. We open now the third sheet. This one is the continuation node in the second sheet. We can appreciate that the drawing of the valve panel at the bottom is confused. To fix this problem, we may proceed like this. First, we delete everything but the line itself. We can see that this point is not connected with this one. Let's see the original geometry in the 3D model. It is a valve panel that creates a closed loop. As the drawing rule only imposes a distortion over the length of the pipe segments, the isometric of a valve panel will generally result open in some point. We can easily fix this with the closed loop command. This command prompts to select the elements that we are going to move, in this case the T and the two vertical pipes. Next, we have to select the line end that will be stretched, but we are warned that we need to line the line to stretch with an axis of the coordinate system. We can use the UCS command to this purpose. We have now the local x-axis parallel to the pipe to be stretched. We select the point to stretch, and next the base point to move. And last, the second point, that is where the base point must be connected, and the command closes the loop. We are now in the position to regenerate dimensions, nodes, and the MTO. And in this way the drawing is finished. Given that the opening point of a closed loop can be anywhere, and this may create a confused drawing, it is better to cause this cut in a convenient location to simplify the fixing. A convenient location is to disconnect the pipe on the side where the panel has less components, for example this point. What we are seeing here is the coincidence between connection points of adjacent components, that is, the very mechanism used to connect components. Therefore, to disconnect the given joint, it is enough to change one of the connecting points by 1/100th of a millimeter. We select the pipe and will change the coordinate of one end, in this case the D1 end that connects to the valve. In this case, any end will do the same. The pipe is not connected to the T anymore, but the connectivity is maintained all the same, as we can see. This is so because both branches are connected. We can extract again the isometric and see what's happened. This one is the first sheet, but we cannot save it because we forgot the previous session open. Let's close all the sheets to avoid this problem. Opening the third sheet, we can see that the panel is now open in the position we choose to. We delete all nodes. In this case, the disconnection is easier than the previous one. It could be fixed using the cut stretch command alone. But let's use the EPLANT command once again. With escape, we say that there are no components to move. We fail again to properly orient the UCS. First, select the end of the line to stretch. Next, the base point, which in this case is the same as the previous point, and the second one that closes the panel. At this point, all the nodes can be rebuilt. We have here a dimension pointing upwards and creating a little confusion. We can rotate it around the axis with the same command that rotates the symbols. We could rotate it another 90 degrees to place it vertical.